just to let you know, with these naming and writing formulas, this nomenclature stuff, the way that you get good at it is by practice, by practice, by practice, all right? So, we're going to be doing a lot of practice on this because, as I said before, if we can't do this, we're going to have problems well into the third 9 weeks, because this stuff is going to be essential to our further studies in chemistry. Now, naming binary molecular compounds. This is a second nomenclature system, so to speak. All right? We have certain ways. We talked about ionic bonding, and we used an ion sheet. This is a different method that is dealing with molecular compounds which are covalently bonded. There are 2 different ways to name binary molecular compounds. We're going to learn the first one today. Probably sometime next week, we're going to learn the second way to name binary molecular compounds. You will see them both ways, so you need to know both ways. It's not like one of the systems is ancient and we don't use anymore. We use them both. We use them both often. So you need to know how to do both of them. Now, binary molecular compounds. First of all, molecular compounds are covalently bonded. Okay, they are covalently bonded units or molecules. Binary molecules will consist of 2 nonmetals. 2 nonmetals. So, when we talk about ionic bonding, we were talking about a metal and a nonmetal. When we are talking about covalent bonding, we'll be talking here about 2 nonmetals. As I said, there are 2 ways in which we will name these. The first way is a stock system, which requires the understanding of oxidation numbers. We've dealt a little bit with oxidation numbers. We've dealt a little bit about stock system. That's somewhat similar to what we were doing with the Roman numerals behind the multivalent metals. Okay, it'll be somewhat similar. Okay, that is, the stock system is what we call the IUPAC way to name things. Now, IUPAC, this is a new term. We probably haven't talked about IUPAC yet, have we? Okay, what IUPAC is it's the International Union of Pure and Applied Chemistry. IUPAC are the chemistry naming people. The chemistry naming people. So the IUPAC way to name is using the stock system. Okay? So basically, the IUPAC is the authority on naming chemicals and nomenclature. Now, we will learn that IUPAC way, the stock system way to use these, to name these binary molecules later on. We're not going to learn that today. We're going to learn the other system today. And that other system is an older system that uses prefixes. It's based on prefixes. Now, there are rules that we have when we are naming using prefixes. So, the least electronegative element is given first. We use the actual name for that particular element. It is given a prefix only if there is more than one atom. So, do not use mono on the first element. All in caps. That's basically what that says. A prefix only if it contributes more than one atom. One atom is mono. So, do not use mono on the first element. Period. The second element is named by combining the prefix of the number of atoms of that element, the root of that element, with an IDE ending. Prefix, base or root of the element, IDE ending. Here are the 10 prefixes that we most commonly use. You should already have those in your notes from the video. Mono, di, tri, tetra, penta, hexa, hepa, octa, nona, deca. Now here's a key part two. Here's a key part two that you should already have. The O or the A at the end of a prefix is usually dropped when the word following the prefix begins with another vowel. Now that said, the O and the A, did it say the I? No, it said the O and the A. So, as I look at this, here are two different ways to express monoxide. Which is the correct way? Which is the incorrect way? Would you drop that O on the left or would you keep it? Drop it. So that is wrong. Monoxide. Whoa, whoa. Pentaoxide or pentoxide. Well, obviously, I spilled the beans. The pentaoxide is wrong. It's pentoxide. Is it triiodide or triiodide? What do you think? Which is the right one? One on the left, because we're talking O and A, right? We're not talking I. So that triiodide with the dually I's right there, yes. So when we have the O and the A followed by a vowel, we will be dropping that. But if it has an I, we do not drop that. Okay? Now, here is our first example that we are going to work today. If I were you, I would copy some more examples down here. Carbon tetrachloride. Now, I look and I see, okay, I see this tetra in here. Okay? I see a tetra in here. I see carbon, that's a nonmetal. Chlorine, that's a nonmetal. I'm dealing with two nonmetals. Okay? Does carbon have a prefix in front of it? No, it does not. No, it does not. So, what I'm going to simply do, I know carbon is a C. What prefix is on carbon? I don't have one. What does that tell me? that it is 1. So do I need to put a 1 behind carbon? Absolutely not. I don't need to write a 1. Chlorine. Okay, because I know I have chloride, so chlorine is my second element. How many chlorines do I have? I have tetra. So the formula for carbon tetrachloride is CCl4. Now, what I see a lot of times, I'll tell you what people do wrong with this, is they try to crisscross. And they write C4Cl. We don't do crisscross. The prefix is with the word that it goes on. So that crisscross is not correct. We don't crisscross doing this. My next example, tetraphosphorus decoxide. I look and I say, okay, I'm just going to break it down. I see that I have phosphorus. How many phosphorus do I have? Tetra, which is 4. I have oxygen. How many oxygens do I have? 10. 10 oxygens. Pretty easy, isn't it? Pretty easy. Dinitrogen monoxide. I'm dealing with nitrogen. How many nitrogens? 2. Oxygen, how many oxygens? 1. Ladies and gentlemen, dinitrogen monoxide. Let's go the other way. CBr4. My least electronegative goes first. It is carbon here. So I have carbon. How many carbon do I have? 1. So is that monocarbon? Not on the first word. We don't use mono on the first word. Remember, it's all caps. Do not use mono on first word. My second element is bromine. Okay? How many bromines do I have? 4. What is my prefix for 4? Tetrabromide. Carbon tetrabromide. P2O3. Okay? I have phosphorus. How many phosphorus do I have? 2. What's my prefix for 2? Do I need to put that? Absolutely. Diphosphorus. What about my next word? Tri. Do I drop the I? No. Trioxide. Diphosphorus trioxide. Pretty easy, right? Pretty easy. What about this one? Okay. Now, I see stuff, folks. Here's the kind of things I see with this one. Barium. Monosulfide trioxide. Okay? I've seen that. I've seen that. What you are doing there, folks, that is totally wrong. totally wrong. Because what is barium? What is barium? A metal. This is ionic naming. Prefixes only go with covalent. So when we're doing these, we were only doing them one. Okay, we were only looking at covalent. The very first thing you need to do is you need to distinguish what way you're going to name it. So the first thing you should ask yourself is, am I dealing with ionic, which is metals and nonmetals? Am I dealing with covalent, which is nonmetals? Because this barium monosulfide trioxide, whoa, craziness. Okay? This is simply barium, and SO3 is a polyatomic. It's a polyatomic ion. What is the polyatomic for SO3? Sulfite. Barium sulfite. So make sure you think, I'm telling you, this stuff is easy using these prefixes. However, it gets tougher when you got all different kinds mixed in there. When you do the homework, when it only has binary molecular compounds, yeah, that's not too tough. But later on, when we do the homework that has all the different systems of naming, all the different kinds in, and you have to distinguish which way to start, which way to go, it gets a little bit tougher. Okay? Any questions for me on this? We got thumbs up here. Let me see front row. Okay, back row. Third row. We good? Thumbs up. Second row. All right. Awesome. Now, you have